Hi everybody, how are you? We're back with lesson number 5, and we'll be talking about today opcodes and operands. CPU does not know what you want it to do. It is not a magical piece of hardware. Just like any other hardware, you need to tell it what to do. This is achieved through an instruction with an optional argument, which is called an operand. An instruction would look like this. This is a valid instruction. MOV AH9. The instruction, this particular instruction copies the value of 9 into the register AH. MOV is a mnemonic for move. When the CPU reads this, it breaks the instruction down into parts. The first part is MOV, the second being AH, and the third 9. Looks at the first part. That, in this case, is MOV. This is recognized as a valid opcode, operation code. Pardon me. If the first part is not identified as an opcode, then at assemble time the assembler will throw an error, providing that it is not a label. Labels are the exception. The next part is assumed to be an operand. If the particular opcode instruction requires an operand, which is an argument, I guess, and none is present, the assembler will throw an error and will not assemble your code. In this case, AH is a valid operand and is recognized as an 8-bit register by the CPU and set to be the destination for the next operand's value. The last and final operand for this instruction is 9. This is an integer literal. The value is tested to see if it is less than or equal to 8 bits, and if it is copied into the register AH. If it's greater than 8 bits, the assembler will throw an error. The full syntax for an instruction follows, so like you can have all of these: label, opcode, operand, comment. For our MOV instruction, there was no label, but the opcode was MOV. The first operand was AH, and the second was 9, and the last part we did not have a comment, but we could have. You can have any combination of these, but you can't have an operand by itself. Whilst an instruction is being executed, the IP register is set with the offset of the next instruction. The IP register is the instruction pointer register. It, as mentioned before, is used for storing the offset of the next instruction to be executed by the CPU and cannot be modified by the software. This register is a 16-bit register. Operands, if you don't already know, is an argument for those who are familiar with high-level languages like C++. Operands can be any data type. For example, a list of operands is shown. Capital A, 65, 41H, 1000000001B, and some text enclosed in quotations. The first example is a character. The second is an integer literal. The third and fourth are also integer literals, and the last is a string literal. Now you may have noticed that suffixing the third and fourth examples are letters. See here? H and B. These letters define what base the number's in. Without a base suffix, the number is assumed to be in decimal, which is base 10. However, suffixing with a D will still work, but there's really no point. All the valid suffixes are D, base 10, H, base 16, O, octal, which is base 8, however nobody ever uses this anymore, so don't worry about that, and B for binary, which is also not used as often, but you find uses for it eventually. Now you can also view the different forms of numbers on the Windows calculator. So if you hold Control, press R, and type CALC, hit enter, brings up the calculator. So the first thing I'm going to do is go up to View and hit Programmer. So now you've got a few more options on the side here. So you can then view numbers in different forms. 65 is actually the ASCII code for the capital letter A. So if we go here and we type in no decimal selected, we type 65, we can go ahead and we can see that in hex, decimal, octal, and binary. Don't worry about these things down here, that's This just toggles the different displays. Alright, and that's all for this lesson. Next lesson we'll be having a look at making your first Hello World program.